Today I'm sharing with you my OpenCode local AI agent and how to efficiently use it. The setup is a part of my everyday work as a lead AI engineer to build application 100% locally. That means no API cost, no external provider, and full privacy because my code and prompt stay on my machine. It also means I can keep working when I'm on the move. I will show you step by step how to install the same setup on your own computer, and we won't stop at installation. We will also use it to build a small real application together. It will be a full stack task management apps. The first tool we need is LMStudio to download and run LLM locally. So go to the official website and download the installer. We will use GLM 4.7 Flash. This model performs very well with coding agent. In chat interface, I send a simple prompt and I'm getting 20 tokens per second, which is okay. Go to settings and enable the local server option. This allows LMStudio to export the model through a local API endpoint. Other tools can then connect to the model. You can also enable authentication and generate access token. Finally, here you can see your local host IP and the port that exports the LMStudio API. To download the model, press the last icon on the left side panel. It will open a list of all available models. For the sake of the video, pick GLM 4.7 Flash and use the quantization that fits your GPU memory. Wait for the model to download. It will depend on your internet speed. Then on the LLM section, we need to change some settings. Go to load and set the context length to max and set max concurrency to 2. Next, go to VS Code website. Download it, then install it. We will use it to view and edit our code. Open it and go to the extension marketplace. Search and install RuCode. In my workflow, I mainly use RuCode for debugging, reviewing code, and applying precise change using AI model. After installing, open RuCode settings. Select LMStudio from the API provider list. There is no need to change the URL. Keep it as the default. Then select GLM 4.7 from the model list. There is also no need to enable speculative decoding, since we currently didn't download a model that works with GLM 4.7. Finally, test everything works as expected by prompting RuCode, a simple prompt like hi. It's normal that the first run will take some time. In the background, a large system prompt was sent to the LLM, so it will need time to process it and answer you back. Finally, I will move RuCode to the right side panel, just for organization. Now, time to install the main coding agent, OpenCode. Go to the website and select the curl option or the homebrew option. Wait for it to start downloading and installing everything. Then on your terminal, type OpenCode and have a quick look on the interface. Okay, now as OpenCode works as expected, let's give it more capability, or what we call skills. Superpower is a very useful one, especially when dealing with app development. To install it, let's visit the GitHub repo and select the installation process that work on your system. I will copy the Linux and macOS command, and on VS Code, under my home directory, I will create a folder called scripts and superpower, and a file called install.sh where I will copy everything. Next, I will give this file execution permission using chmod plus X, then run everything, wait for it to install, and finally let's check. Open OpenCode, type skills, and as you can see, this is the list of the new added capability. Now, to give OpenCode the capability to fetch latest software documentation, to avoid deprecated library and vulnerability, we will need the contact 7 MCP. So go to the website and grab your RPA key. It's 100% free. Keep it safe. We will need it during OpenCode configuration. This is the last mile to make our AI dev agent behave like a senior software engineer. And let's configure it. The first section is compactation. Basically, the model will compress its memory by summarizing its context. This is useful if your available GPU memory doesn't allow you to use a large context, but you will lose some quality. The provider section is where we set up the LMStudio API and the model that will be reachable by OpenCode. In our case, I added GLM 4.7 Flash, and you can add as many models as you need and switch between them in the OpenCode interface. MCP. Here we need to add the context 7 URL and API key. Also, you can see that I'm adding other MCPs. Currently, they are out of the scope of this video, but you can try them if you want. Finally, the watcher configuration. It's simple but important. This is the list of file patterns that I want the agent to ignore. I'd never add them to the context. Now we are ready for the fun part. Let's build a small full-stack application for task management. I prompted the agent the app specs and the technical stack to use. The agent starts to analyze the requirement and the app aspect. Basically, it's trying to understand what I'm willing to build and check the current directory. Is it empty or is it already code base? The right side panel will show you the size of the used context and the cost. In our case, it will be 0. Also, this is where the agent shows the active MCPs. Now, the agent starts to ask questions in order to validate with you that it was able to understand the app specs and validate the technical aspect with you. Next, it will automatically trigger the context 7 MCP to fetch the documentation of all the libraries that it will use in order to develop this app. For the sake of this video, I sped up the agent planning phase. It managed to get documentation, construct the app design, and the structure of the APIs. This planning phase took 8 minutes for the agent to finish. Remember, everything is running locally. Finishing the planning process, the agent is asking to start implementing. To begin, press Command plus Tab to switch from plan mode to build mode and prompt it to proceed with the implementation. In VS Code, open the file browser on the left side panel. You will see folders and files appear. And when working with AI agent, you must always apply these golden rules. Zero trust. No matter how smart your agents or models are, you must always supervise the outcome. Ensure that all rules are followed and that the code aligns with best practice and company compliance. At its current state, the agent has built the front-end and back-end project structure and started implementing the back-end code, which is a good starting point for aspects related to application security and database. If you refer back to the prompt, I didn't mention this explicitly. Yet the agent was able to figure it out on its own, which reflects a well-structured workflow. For free model running locally, this is impressive. Do you remember RuCode, the AI agent that we installed? Let me show you how I use it. When OpenCode continues to write code faster than any human can read, I rely on RuCode to ask it a question, to explain some part of the code. I can select the whole file or just a single line and ask for modification or explanation. In my experience, it's better to have separate development and debugging environment because a single prompt can disturb your code base. I asked RuCode to explain the config.py that was implemented by OpenCode. And as you can see, it provided detailed explanation. As I continue exploring the code, I found that OpenCode placed all the Pydantic model in the init file. I do not approve this structure, and it's not the right location for data model. It's recommended to play them in a separate file based on business logic and software architecture. I decided to not interrupt OpenCode to fix this now, as it's currently continuing to write code and performing very well. Instead, I will ask RuCode to make this change. I prompt RuCode to place each data model in a separate file. It took the time to analyze my request and ask questions. I approved the plan and asked it to start working on the change. The change will happen in parallel with OpenCode continue to develop the application. Something to notice is parallel token processing and generation will slightly impact the performance. Before starting the edits, RuCode created a checkpoint, which is a useful mechanism in case something goes wrong. Now, the first data model file is being generated. It's priority.py. RuCode also asks for approval before saving this file. Currently, I'm keeping full control over RuCode generation to avoid breaking the project code base. Once I'm confident that the generated file follow my coding standards, I will grant more autonomy and allow it to write directly. At this stage, I'm satisfied with what RuCode plus GLM 4.7 are generating. The files are well organized, and the data model and enums classes related to business logic are properly encapsulated. Finally, to avoid breaking the code base, RuCode import all entities in init.py. For now, I will accept this change to prevent misalignment between RuCode and OpenCode.
6.5 hours later.
After 6 hours of token crunching, we are getting our first running demo. Each component, the database, the backend, and the frontend, is deployed as a Docker container. Here we are on the login screen, the model-populated database with dummy data for demonstration purposes. First, let's log in. Alright, John is managing two task boards, the test and the engineering team. The overall design looks good and responsive. Let me play the Database Explorer side by side with the UI to ensure that changes are reflected in both. Database design is not optimal as it contains loops, and I will work on that later. Now let's add new tasks and check if it will get persisted. The UI work as expected, and let's refresh the database and we must see this new task. And yeah, it's persisted. Now let's update the tasks. As you know, updating is more complex than creation. I will change this task from to do to done. Okay, the UI reflects this change and move the task to the to do column. After refreshing, the database is updated as well. Now I will add the task to the testing team. I need to ensure that database constraints are respected. The task must be assigned only to this team to avoid any leaks. Great, every part of the app is dynamic. Nothing is static or stored in memory. Last thing to test is new user creation. I will give this user an email and a password. There is no email verification, and the user is logged in directly into the dashboard. Great, this user is new and should not have any teams. Let's check the database. The user is well persisted, and the password is stored in encrypted form. We are reaching the end of this video. Keep your coding agent simple is the way to go. There is no need to install multiple MCP or skills. Stay involved in the loop and always review what the agent generates. Using two agents like OpenCode and RuCode helps you to stay organized and move faster. If you found this useful, please like and subscribe to the channel. Thank you for watching and see you in the next video.